Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to go through how to analyze an AC circuit or that has only a resistor hooked to a sinusoidally varying voltage source. Now before I start talking about the circuit, let me talk about this picture on the right. So hopefully you've seen my video about phasor diagrams and what they are, but I want to do a quick little reminder. So a phasor is a rotating vector. So in this example here, imagine this coordinate system. This vector here is going to represent the input voltage, which is equal to V max sine omega t. And then this vector is rotating around at an angular velocity omega. So this angle theta would equal omega t. And the omega is 2 pi times the linear frequency. So the instantaneous voltage is the projection of this vector onto the y-axis. So I'm going to draw that in red. So when this vector is in this position, this distance in the picture represents the instantaneous voltage. You'll notice, when this thing gets all the way up here, that would mean the voltage is its maximum value. And when this phasor diagram is all the way over here, the voltage would be 0. And this is all the way down here. The instantaneous projection might look something like that, and so forth. So again, phasor diagrams are just, kind of a graphical way to analyze these circuits. Now, one of the things we need to understand how to do to analyze a circuit that has a whole bunch of things in it, like a capacitor, resistor, and an inductor all hooked to one source, is we have to understand the phasor diagrams for each one individually. All right, so when we look at this circuit, we have a resistor here, and the voltage across a resistor is equal to IR. Now you notice I wrote little I here because you've got different types of current. You've got DC current and AC current, and I'm in the AC world here, and it's pretty standard notation to use little v's and little i's when in the AC world for AC currents, AC voltages. All right, and then this is our symbol for our AC voltage source. It's equal to V max sine omega t in general. So these are analyzed by Kirchhoff's law. So if we just pick a spot and do a loop, it's a pretty simple short equation here. We end up with V max sine omega t minus IR equals 0. And what I'm interested in is the I, the current. So it's just a quick algebra move here to solve for the current. So we get V max over R sine omega t. Now this equation here has got some important things. One, this is dimensionless, so this thing's V over R. You'll notice the R is right where it should be in the resistance spot. Keep that in mind later when we're talking about capacitors and inductors. What is in this spot is very important. Later on we'll find it's not going to be the resistance, it's going to be something else. This quantity, V max over R, represents the maximum current in the circuit. If I wanted to, I could write this I max sine omega t. I don't have to, but I could. This is just a little shorter to write. Now, a very important thing to recognize is that because this is sine omega t, and I compare that to the input voltage here, V max sine omega t, the sine omega t's are the same. And what that means is in our phasor diagram, the current is in phase with the voltage. So what we would do in our phasor diagram is, I'm going to draw this in red, we can draw a current phasor now that's exactly in phase with the voltage, the input phasor, right? So there's our I of t here in red. Now you'll notice I drew that shorter than the input voltage. You might wonder why. Well, the answer to that is just because I want to show that there's two separate vectors here. There's this red one and the black one. It doesn't even make sense to compare their lengths. I could have just as equally drawn that red one longer. It doesn't make sense to say 10 amps is more than 4 volts or anything like that. If you're going to compare the length of two vectors, they have to be the same thing. They have to have the same units. So analyzing a resistor source is analyzing a resistor hooked to an AC voltage source, no problem at all. A very important fact here is that the current phasor is in line with the voltage phasor. And I think what I'm going to do here is make separate videos for resistors, capacitors, and inductors. But remember this, as you go through these videos, this is really important. If you're watching this video, take notes. Draw this picture. And you need this picture right here. This is going to be really important, that the current and the voltage are in phase for a resistor. So go ahead and get that done, and I'm going to just start my next video.